All right, all right, all right. Here we go. Assignment 3E. This is just more differentiation and dealing with the tangent line. Again, what a derivative is when you take a derivative in the first place, no matter what kind of rule you use, if you have to use the product rule or the quotient rule or the power rule, whatever. When you take a derivative of something, you are finding the slope of the tangent. Finding the slope of the tangent. And that's an instantaneous rate of change. Okay, an instantaneous rate of change is the slope of the tangent. Okay, let's see what they have in store for us today. We begin by finding the equation of a tangent line. Okay, not a problem. In these examples, find an equation of the tangent line of the graph at the point. So we're trying to find the equation of the tangent line of this that goes to the point -5, 5. Okay, use a graphing utility to verify that, and then use this thing to confirm the results. All right. Okay, not a big deal. Okay, so the hardest part about this, and the main part of this question, is finding the equation of the tangent. So again, what a tangent what a derivative is a slope of the tangent. So I already have the point. So whatever this picture does or whatever, it's say that this is there, and this is the derivative. I know that the point is going to be -5, 5. But what I don't know is what is the slope of that very specific tangent line. And so that is my big question right there. And so here I need to start by the derivative. So f prime of x. So this is a quotient, so bottoms up. Derivative of the top minus, leave the top alone, derivative of the bottom, divided by the bottom, squared. So this is the derivative. This is x plus 4 minus x. And this is 4 over x plus 4 squared. That's the derivative. Now, why did I do that? Because I'm after the slope of that tangent line. So yes, this will give me the slope, but where do I specifically want the slope? Well, I want it when x is equal to -5. So plugging that into my derivative, -5 plus 4 is -1. -1 squared is +1. This is equal to 4. So what I just discovered is this, again, of my hypothetical picture that I just kind of made believe here. I have a point that is at -5, 5 that has a tangent line. What is the equation of that tangent line? Well, what I just found out is I took the derivative of the red line, and I found at -5, this has a slope of 4. That has a slope of 4. So now all I need to do is write the equation of that line. And so I have a point and I have a slope. So let me kind of minimize this, give myself a little bit more working room here. So I took the derivative, and then I used that derivative to find the slope at that specific point of -5. So next is the equation. So y minus y1 is equal to m, the slope, of x minus, so minus negative is plus, x1. That is the slope of the tangent line. Okay. Graph them both and then use this tangent thing. And I made a mistake right here. This should be wrong. and use your calculator to verify this. All right, so I'm going to kind of kill two birds with one stone. I'm going to graph both my equation and my tangent line pretty much all at once. So I fire up my calculator and I graph my my equation. Now, if you take a close look at my calculator right here, this is what some people will enter, meaning to be putting in x divided by x plus 4. This is not x divided by x plus 4. What you really kind of want to do in your calculator is get in the habit of using parentheses. You need to clarify what is your numerator and what is your denominator. All right, so it's clear that the numerator is x, but it's not clear that the denominator is x plus 4. Because what this calculator will do is it'll take x divided by x and then just add a clunky old 4 onto it. So what you need to do is you need to put a parentheses around the numerator and the denominator when necessary. So now this is x divided by x plus 4. All right, so zoom 6. And there is my picture. So that's pretty much right. It's a little off on the location, but it's pretty good. So at -4, it looks like we have a vertical asymptote. And this goes up, this goes out. Okay, there is the picture of my graph. Now, what is the picture of my tangent line? And this is a utility that I really didn't even know existed, and it's like, wow, this is a great thing. Okay, you see the gold writing right here above the program. Okay, I know I wrote stat. It's not under the stat button. It's under draw. Draw. I'm going to draw. So I go shift and then program. Okay, that brings up the draw. And you'll notice the number 5 is the tangent. I'm going to draw a tangent. I hit enter. All right, now what I'm going to do is I'm going to physically type in what x value do I want my tangent at. And I want my x value to be -5. So -5, and then boom, there's the tangent line. And what it also spits out is the equation of that tangent line down here. So it says y is equal to 4x plus 25. What do you know? Yay! So at -5 of this, and this is the equation of our tangent. Booyah! All right. Number 75, what is the equation of this tangent line? Okay, so again, we begin with the derivative. So the derivative of the first is 1 plus, leave the first one alone, derivative of the second, that's e to the x, and that's still e to the x. Derivative of e to the x is e to the x. So this is e to the x plus x e to the x minus e to the x. And so I have an e to the x minus an e to the x. So this is equal to x e to the x. That looks like that, no? So that is my derivative. Hopefully they'll be kind to us when they get us to this point. And so we want to know what is the slope when x is equal to 1. And so that's going to be 1 e to the 1. So this is going to be a constant. That's just, yeah, obviously it is a value. So. And so that is 1 e to the 1, or aka just e. My slope is e. That's a number. It's a number. E is a number. So here we go, equation time. Y minus y1 is equal to m e to the 1, x minus x1. So this is e to the 1x minus e to the 1. A lot of times you'll just see that written as e, right? But it's hard for me to say e without getting some sort of exponent on it. So e. So ex minus e should be the equation. That's a line. You know. That's the equation of the tangent line through that point. All right, just to kind of give myself a little bit of reference, so when my calculator spits out numbers and stuff like that, how do I know if my numbers are correct and it matches my actual equation? So what I'm going to do is I'm going to just ask myself, what is e to the 1? And as I said, it's a number. So if my calculator spits out 2.7183x minus 2.7183, I know that I'll have the correct answer. So I'm just kind of hold that in reserve right there and see if I have the correct stuff. All right, so first is to graph the actual. So x minus 1, e to the x. All right. So what that original graph kind of looked like is looks like an asymptote that dips down and then skyrockets, something like that. We are taking a look at a point at 1, 0. So I'm assuming it's right there, 1, 0. So what I'm going to do is I'm going to draw, so second draw my tangent line at x is equal to 1. So there's my tangent line. And let's take a look at the equation that they give me. 2.7183, good enough? I don't know if they go over, yeah, whatever. It was right on the money. It was exactly what we thought it was. So we got it right. Okay, again, this is asking for horizontal tangent lines. Horizontal tangent lines imply that the derivative is equal to 0. That's what it means, is the derivative is equal to 0. The slope of the tangent is equal to 0, horizontal tangent lines. Determine the points at which we have horizontal tangent lines. So we need to begin with the derivative, bottoms up, derivative of the top, minus the vice versa. All right, so again, one of those math things. I need to make this thing equal to 0. Okay, that's fine. Now, what do I do when I want to make this equal to 0 when you have a fraction? Okay, zeros don't come from the denominators, by the way. Or if you do set it up equal to 0, hey, I want to know where is this derivative equal to 0. So you'd say x squared minus 2x all over x minus 1 squared is equal to 0. What's the very first thing you would do? You would multiply that out. So, and it goes to 0 anyways. So in essence, long story short, zeros don't come from the denominator whatsoever. Okay, it's impossible to get a 0 from the denominator, right? Now, I just have to watch out to make sure that x is not equal to 1. That I do know from the denominator, but I'm not going to get a 0 from the denominator itself. So I set it up, I can GCF out an x, and so I have x's of 0 and positive 2. That is where I'm going to have horizontal asymptotes, or excuse me, horizontal tangents. So I will have an x value of, one of the points will have an x value of 0, the other will have an x value of 2. Plugging and chugging into the original, this is going to be 0, 0. Plugging into the original, that's 4 over 1, so that's 4. There's your points. Sometimes they'll ask for points, sometimes they'll ask for x values. Okay, again, horizontals. 8x minus 16. Okay, here we go. Derivative time. Bottoms up. Derivative of the top. Minus. Leave the top alone. Derivative of the bottom. It's still e to the x. All over the bottom. Squared. I'll multiply now. Let me kind of minimize this so I can kind of keep my work going here. So I have these e to the x's in the numerator, so that's 8 plus 16, so this is 24. All right, so that is my gross. That is my derivative. Now I need to know where is that derivative equal to 0. That will be the x values of my horizontal tangent. So I need to know where is 8x e to the x plus 24 e to the x equal to 0. We don't make it easy on the guy. E to the x, I'll take a negative 8 e to the x. That leaves x minus 3. Right? This will never, ever, ever, never, ever, ever, never equal 0. Okay? So you're not going to get a 0 from that outside x right there. The only that will exist is this positive 3 coming from that inside portion. So positive 3 is the x value that will create your horizontal tangent. Now, what is that as a point? So that is the x value of our point. And so what we're going to do is you got to plug that into the original function right up there. And so if I have an x of 3, my y value is going to be, I'll just, 2 over e to the 3, so this is e over e to the 3, whatever that is. Whatever that is, it's not my problem. Somewhere there. Find the second derivative. Find the second derivative, we need to start with the first derivative. 4 times 3 over 2, so that is 12 over 6, that's 6, x minus 1, so that's 1 half. Yeah, so 3 over 2 times 4, and then subtract 1. Second derivative, okay, 1 half times 6, minus 1, so it's either that or 3, one of the two. Find f prime of 2. So f prime of x itself is 2 g prime x plus h prime x. So you can excuse me, as you were, you can add just fine. So f prime of 2 is 2g prime of 2 plus h prime of 2. And so that's 2. G prime of 2 is negative 2 plus h prime of 2 is 4. And so this is going to be negative 4 plus 4. Okay, f prime of x is bottoms up, so it's a regular h derivative, and then minus the opposite of what you just had, so h prime regular g all over the denominator squared. So that's the derivative. Now I want to know f prime of 2. So that's going to be h of 2, g prime of 2, h prime of 2, g of 2, all over h of 2 squared. All right, let's put in some numbers. H of 2 is negative 1. G prime of 2 is negative 2. H prime of 2 is 4. G of 2 is 3. H of 2 is negative 1. So this is going to be what? 2 minus, Jesus, I almost said 7. I'll try that again. 2 minus 12 over 1 is negative 10. Multiple choice, choose B. If f is differentiable, which one could be false? Okay, if it's differentiable, then it absolutely is continuous. Okay, so it has to be continuous to be differentiable. Limit as x goes to c if f of x exists. Yes, that's part of being continuous. F prime of c is defined. Yes, that's part of the differentiability test. F double prime, I don't know. That's the one that it could be true, it could be not, it could be false. Again, differentiability. So differentiability implies it's the continuity test but of derivatives. So to be differentiable, first and foremost, it must be continuous. And then we got the limit as x goes to c from the left equal to the limit as x goes to c from the right. Okay, equal to some number, I'll just put in a number like 5. That implies that the limit as x goes to c of the derivative is equal to 5. So you can kind of skip over these first two steps sometimes, but the limit has to exist. The point has to exist, and the limit has to be equal to the point. The continuity test is the exact same thing, just take away all the primes. What's the second derivative of that? Oh, gross. All right, here we go. H prime. Bottoms up. I'm trying to keep mentally moving to the 5. I'm guessing right now it's going to be that bottom dude right there. I'm guessing because you keep squaring the denominator, and so in my mind that will end up to be an x to the 4. I feel like I'm doing this wrong. All right. I'll clean this up, and if you have a question on this one, I'll take it up in class. I feel like I'm doing this wrong. Let me hammer it out a few times, and then I will bring it back to you. So, yeah. Anyways, I'm just going to put that before I, drag this video on forever and ever and ever. I'll come back to it, and we can figure it out. All right. Have a good day, everybody. Keep smiling.